Okay, we are here again in the Caldera del Rey, southern Tenerife. This is a Phreatomagmatic top ring, and everything here is controlled by interaction of water, which is the coolant, and the magma that is the fuel. If the proportion are, depending on the proportion, is the energy of the eruption. If there is too much water, then there is very little energy, and you get very few explosion. When the proportion is, I think I remember, is about a third, then the energy is very high, and you get very explosive eruption, and the lava is fragmented in very fine, and you can see this layer, the whiter layer. That means that was a very explosive event. And in the rest, you get pieces of rocks that are, how you say, from the ghost rock, that sometimes make an impact sack. It's called bomb sacks. And in the white layer, I think I see from here, there is some occasionally lapilli. That's very nice signature of this Phreatomagmatic. That means that the very fine dust with the rain and with the water makes this kind of small occasionary balls that run and make this type of lapilli. But you see that the lower part is just very little energy, and it's a lot of, how you say, rocks, horse rocks.
Lithic rocks.
Lithic rocks.
Yes, but
So the only very high energy event here is this layer, this fine layer.
and there's of course a little finer band again, a little higher up.
Exactly.
And then you
because
know,
they are rhythmic.
exactly, you get these rhythmic layers of very intense explosive activity, and then less intensive. And if we go a little over here, we actually see that there's more of these white layers. These are the really dangerous ones. They reflect
Actually, this white layer means how you say, lateral explosion.
Yes.
A lot of the research done in these top rings has been done with nuclear explosions.
They are very
because
similar
they behave
indeed.
very similar.
So, and if we look up there, we see more of those white fine-grained bands, and then it
Small
looks that
explosive,
there was a
because
quicker
it's less water.
succession.
It's less water.
Yeah, could be.
And the ratio water magma is more efficient.
So we're walking along now, and here the phase shift changes, and here we get a lot more of those fine-grained layers.
Now you can see here that the rocks, the lithic fragments, very heavy, are pushed very high, and they make these bomb sacks. When they fall, you see here, the impact.
Yes, into a soft substrate.
Exactly.
And here we have another one of those very fine-grained layers, very explosive, very high energy. And then here is a big lithic fragment that kind of impacted through one of the previous white layers.
Exactly. That's a big one, so that means that it was very energetic.
Yeah, this was thrown out and was impacting into the soft substrate here. And there we have beautiful cross-bedding and surge deposit type material there with sedimentary kind of features. Very lovely.
You can see the rhythmic.
Yes, very nice layers here. So fantastic. Okay, I close with the last look here down the section. Thank you so much, Juan Carlos.
Okay, bye-bye.
And here's a look down the section. And I'd like to close with swinging around, because just in the distance over there we actually have La Gomera. So there you get the sense of an ocean island chain. Let's see whether I get this into the camera here. So there's the shield of La Gomera there in the far distance, and it looks like a upside down, sort of a lying warrior's shield, hence the term shield volcano. Of course it's deeply eroded with loads of gullies, but we don't see that from here. And this is the island of La Gomera. Thank you very much, all the very best, and talk very soon.